Hi student, this is Sivakumar. 11th standard mathematics chapter number 6. Two-dimensional analytical geometry. In this chapter, things to be learnt: the equation of a line in different forms, whether two given lines are parallel or perpendicular, the distance of a given point from a given line and between two parallel lines, the family of straight lines for a given condition, the equation of pair of straight lines, angle between them and angle bisectors. So these are the things to be learnt in this chapter. Now, what do you mean by locus of a point? The locus, that may be a circle or angle bisector or a straight line, whatever it is. A point is an exact position or location on a plane surface. A point is an exact position or location on a plane surface, that is called a locus of a point. So what do you mean by locus? The proper definition here it is: the path traced out by a moving point under certain conditions is called the locus of that point. Alternately, when a point moves in accordance with a geometrical law, its path is called the locus. The plural of locus is loci. So you are given different types of locus. You can easily understand the concept of locus now. Here I start with a circle. Listen carefully. There is a fixed point. There is a moving point. Here O is the fixed point, P is the moving point. The geometrical condition is the distance between O and P is always constant. By obeying the geometrical condition, you have to move the point P. So always OP is constant. That is R unit, for example. So if you move on, if you keep on moving the point P, always OP to be retained as R units. So you will be getting one shape. That shape is called a locus. What shape it is? It is a circle. Circle is the locus of the point P. Here OP is a radius, because O is the center. The point P which lies on the circle, therefore OP is a radius. Like that. Next one is angle bisector of angle XOY, x-axis, y-axis. This is a geometrical condition. A point P moves such that it is equal distance from two fixed lines OX and OY. OX and OY. A point P here, if we draw a perpendicular to x-axis, let it be PM. And if we draw a perpendicular line to y-axis, PN always equal according to the geometrical condition. Suppose a point P is here, PN. Suppose a point P here, PN always equal. So definitely you will be getting a line. That line is the angle bisector of angle XOY. Yeah. This, what do you mean by angle bisector? It is a 90 degree. XOY is a 90 degree. This line divides the angle 90 into two equal angles. Since it is dividing the angle, therefore it is called angle bisector of angle XOY. So 45 degree each. So angle bisector is the locus of the point P. Now third one, so perpendicular bisector. We have two fixed points A and B. There is a moving point. The condition is PA and PB are always equal. You have to obey the geometrical condition. So while obeying the geometrical condition, you will be getting a shape like that. PA, PB, suppose the point P here, PA, PB, suppose the point over here, P, PA, PB, always equal. So you definitely will be getting a straight line. That straight line is passing through the midpoint of AB. At the same time, it is perpendicular. So what it is called? The perpendicular bisector of the line segment AB. So the perpendicular bisector is the locus of the point P. Okay. Procedure to find the equation of locus of a point. We have totally 4 points. Very important one. Listen. If you are finding the equation of the locus of a point P, assign coordinates say h comma k to the point P. So in general you have to consider as h comma k. Express the given conditions as equations in terms of the known quantities and unknown parameters. Eliminate the parameters. I tell about the parameter later on. Eliminate the parameters so that the resulting equation contains only h comma k and known quantities. Finally, h to be replaced by x and y should be replaced by y. What is given here? Replacing h by x and k by y in the resulting equation. The resulting equation is the equation of the locus of the point P. So the final equation of the locus in terms of x and y. Okay. Here I have given 5 Cartesian equation in terms of x and y. So these are the parametric points. See, Cartesian equation of a circle, if the center is the origin and radius r units, x square plus y square, that is equal to r square, circle equation. Then parabola, actually 4 different parabolas are there, open right, open left, open up and open down. See, this is open right parabola, this is open left parabola, open up parabola and open down parabola. 4 different parabolas are there. So open right parabola, that's a standard form of the parabola. It is a locus. That is the equation is y square equal to 4ax. General name locus. Okay. Now ellipse. Ellipse, actually 2 different ellipses are there. Elliptical in shape. You will be studying elaborately when you come for 12th standard. That is a separate chapter. The major part is the minor part, major part along x-axis, minor part along y-axis. Here, major part along y-axis and minor part along x-axis. So, 2 different ellipses are there. This is the standard types of an ellipse. X squared by a square plus y squared by b square, that is equal to 1. This is a parametric point, a cos theta comma b sin theta. This is the parametric point for that parabola, at square comma 280. And r cos theta comma r sin theta is parametric point for the circle. Next one, hyperbola. Hyperbola also we have 2 different hyperbolas. Here a left open, right open. Here a top and bottoms are open here. So 2 different. Okay, here x-axis transverse axis, or it is called x-axis transverse axis, y-axis conjugate axis. Here y-axis transverse axis, x-axis conjugate axis. All things will be learnt in 12th standard elaborately, right? So this is a standard equation of hyperbola. Next one, rectangular hyperbola. Rectangular hyperbola xy, that is equal to c square. This is the rectangular hyperbola curve, both in first quadrant and one in first quadrant, another one in third quadrant, x-axis, y-axis. So what is the equation xy, that is equal to c square. This is a parametric point ct comma c by t. Particularly for the parametric point of a circle, I explain now, others and I will be studying later on. Now consider a circle, the x-axis and the y-axis. Take a point P on the circle, that O is the origin, center as well as join O and P. The OP is the radius, considered as R unit. Now from P, draw a perpendicular line to x-axis, let it be M. Here OP makes an angle theta with x-axis. We know that the side opposite angle is opposite side, the side adjacent to angle is adjacent side, and the side opposite to 90 degrees is called hypotenuse. Okay, I consider the point as x comma y. General point on the circle is x comma y. Because you have the equation of a circle, if center is origin and radius or units, what is the equation? X square plus y square, that is equal to r square. Now, since it is x comma y, from origin to the distance OM that is x unit and PM that is equal to y unit, you know very well. If it is 2, here 3, what point it is 2 comma 3, like that, x and y, x comma y. Now, I am going to find out cos theta and sin theta. Cos theta that is equal to adjacent side by hypotenuse. Adjacent side that is equal to x, hypotenuse that is equal to r, x by r. From this you can find out x, you have to cross multiply r cos theta that is equal to x, x that is equal to r cos theta. Like that, sin theta that is equal to opposite side by hypotenuse, opposite side that is equal to y, hypotenuse that is r, correct, y by r. If we cross multiply, we will be getting y that is equal to r sin theta. Now, x comma y, general point x comma y, that x can be replaced by r cos theta and y that is equal to r sin theta. This is a parametric point. How it comes? I have given here r cos theta comma r sin theta. So, if we replace x by r cos theta and y by r sin theta, look at that, x that is LHS equals x squared, x that is equal to r cos theta the whole square plus y that is equal to r sin theta the whole square, that is equal to, while squaring we will be getting r squared cos squared theta, here r squared sin squared theta. You can take r squared as common, you will be getting cos squared theta plus sin squared theta, that is equal to r squared into, you know that cos squared theta plus sin squared theta that is equal to 1, r squared into 1 that is equal to r squared. Look at the RHS. I hope that you have understood the concept of parametric point for a circle. Like that, that is a parametric point for parabola, ellipse, hyperbola and rectangular hyperbola. See, look at that. The standard form of the parabola, y squared that is equal to 4ax. Y squared that is equal to 4ax. The parametric point what I have given? 80 squared comma 280. This is the x coordinate, this is the y coordinate. I am going to replace here. The LHS and the RHS will be balanced. Y that is equal to 280. If it is 280 the whole square, 4a into x that is equal to 80 square. 2 squared is 4, a square, t square. Here also 4, a into a square, t square. Look at that, LHS and RHS are balanced. So that is a parametric point. Next one, a cos theta comma b sin theta. If we replace x by a cos theta, listen, x squared means a squared cos squared theta. A squared cancel, cos squared theta. Here y that is equal to b sin theta. If you replace y by b sin theta, you will be getting b squared sin squared theta. B squared get cancelled. So here you will be getting cos squared theta. Here you will be getting sin squared theta. Cos squared theta plus sin squared theta value 1. You will be getting the RHS. Like that, a secant theta comma b tan theta is a parametric point for a hyperbola. I am going to replace x by a secant theta. If we replace, we will be getting a squared secant squared theta. A squared get cancelled. We will be getting secant squared theta only. Like that. If we replace y by b tan theta, we will be getting b squared tan squared theta. B squared get cancelled. So, we will be getting secant squared theta minus tan squared theta. You know the formula for secant squared theta minus tan squared theta, that is also 1. Like that, for rectangular hyperbola, ct comma c by t, if we replace x by ct and y by c by t, x that is ct, y by c by t, tt get cancelled, we are getting c squared. Look at the RHS, c squared. So, that is a parametric point of a parabola, rectangular hyperbola. Okay. Here r and theta are the parameters. The parameters means, for example, different circles will be getting different radius and different angles. Suppose the point, if I consider the point P over here, OP, PM, so angle will be changed definitely. So, things which are changed, that's called a function as well as the parameter. So, theta and r are the parameters, like that. Here T is a parameter, A is the constant one. and here theta is the parameter, theta is the parameter, and here t is the parameter, c is the constant. So again I tell you, here c is the constant, t is the parameter, a is the constant, theta is the parameter, a is constant, b also constant, theta is the parameter. Here a constant, t is the parameter. Here theta is the parameter. Actually r is a constant, not parameter, because r is a fixed radius. For a circle, radius is the constant one. So theta is the parameter. Okay, sorry. Now note this one, sin squared theta plus cos squared theta, that is equal to 1. You know very well. Secant squared theta minus tan squared theta, that is equal to 1. Cosecant squared theta minus cot squared theta, that is equal to 1. Distance between the 2 points, you know very well. Square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Midpoint of the line segment joining the 2 points, x1 plus x2 by 2 comma y1 plus y2 by 2. Centroid of the triangle ABC, x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. Then section formula, internally the point P divides internally the line segment AB in the ratio m is to n and m is to n externally. Here is the internally formula, this one is the externally formula. The only change, instead of plus here minus. Now we can get into that exercise 6.1, problem number 1. Question number 1, find the locus of the point P if for all values of alpha the coordinates of a moving point P is, two subdivisions are given. In the locus of the point P, the alpha to be eliminated, very simple one. You are given the point, the final result, the alpha, the parameter alpha to be replaced, to be eliminated. Subdivision number 1, P of 9 cos alpha, 9 sin alpha. Here this is the x coordinate, this is the y coordinate, x and y. Here x that is equal to 9 cos alpha, y that is equal to 9 sin alpha, which implies x by 9 that is equal to cos alpha, and which implies y by 9 that is equal to sin alpha. 9 comes to the denominator. So cos alpha that is equal to x by 9 and sin alpha that is equal to y by 9. We know that cos squared alpha plus sin squared alpha that is equal to 1. You know the identity. Here cos alpha that is equal to x by 9. Sin alpha that is equal to y by 9. X by 9 the whole square, sin alpha y by 9 the whole square, that is equal to 1. That is x square divided by 9 square is 81. Like that, here y square divided by 81 equals 1. So we have a common denominator 81. So write the numerator x square plus y square equals 1. So x square plus y square equals 81. Ones are 81. That's all. This is the locus of the point P. Look at that. Automatically the alpha has been eliminated. This is a Cartesian equation of the circle. X square plus y square that is equal to 9 square. What form it is? X square plus y square equal to r square. R is the radius. Here r is 9 units. Now subdivision number 2. The given point is P of 9 cos alpha, 6 sin alpha. 9 cos alpha, 6 sin alpha. This is the x coordinate and y coordinate is 6 sin alpha. Here x that is equal to 9 cos alpha and y that is equal to 6 sin alpha, which implies x by 9 that is equal to cos alpha and which implies y by 6 that is equal to sin alpha. We know that again cos square alpha plus sin square alpha that is equal to 1. cos square alpha plus sin square alpha, that is equal to 1. Cos alpha, that is equal to x by 9 and its square. Sin alpha, that is equal to y by 6 and its square, that is equal to 1. That is x square divided by 81, y square divided by 36, that is equal to 1. Then you have to take the LCM for 81 and 36, or else let it be automatically alpha has been eliminated. This is the locus of the point P. This is of the form x squared by a square plus y squared by b squared equals 1. It is an ellipse, ellipse equation. Here circle, for your reference I write here, this locus is a circle, here locus is an ellipse. For your reference I write the form x squared by a squared plus y squared divided by b squared equals 1. 6 squared and 9 squared. Here circle equation, that is form x square plus y squared equal to r squared. Over problem number 1 is completed. Then I will be teaching for number 2 in the next video. Thank you, children.